In this video, we will talk about Coulomb's law applied to the electric force vector. If at 2 points A and B in space, we put two charged particles of respective charges QA and QB, each particle interacts with the other one, exerting on it an electric force. The force exerted by the particle of charge QA on that of charge QB is given by this formula, where K is the Coulomb's constant and has a positive value that depends on the medium where the particles are. AB is the distance between A and B, and UAB is a unit vector having the same direction as that of vector AB and having point B or any other point in space as its origin. Note that the force exerted by the particle of charge QB on that of charge QA is obtained by interchanging A and B, which gives the following formula, where UBA is a unit vector having the same direction as that of vector BA and having A or any other point in space as its origin. Note that in both formulas, K is the same, the products QA, QB, and QB, QA are equal, and the distances AB and BA are also equal. This means that the only difference between the formula giving FAB and that giving FBA is the unit vector. We already know that if two electric charges are of the same sign, they repel each other, and if they are of opposite signs, they attract each other. And in this part of the video, we're going to verify this using the already explained formula and represent the corresponding electric force vector. For this purpose, we consider the four possibilities displayed on the screen. Let's start by drawing the unit vector UAB, which is independent of the sign of the charges QA and QB. In the formula, K and AB squared are positive values. Thus, if the product QA-QB is positive, which means that QA and QB are of the same sign, both positive or both negative, the vector representing the force FAB exerted by the particle of charge QA on that of charge QB and the unit vector UAB have the same direction. Vector FAB shows that the electric force is repulsive in these two cases. Likewise, if the product QA-QB is negative, which means that QA and QB are of opposite signs, QA positive and QB negative, and vice versa, vectors FAB and UAB have opposite directions. Vector FAB shows that the electric force is attractive in these two cases. To represent the force FBA exerted by the particle of charge QB on that of charge QA, we start by drawing the unit vector UBA, which is independent of the sign of the charges QA and QB. Then we represent vector FBA applying the same method used to represent vector FAB. And we get to the same conclusion, which is the force is repulsive if the charges are of the same sign and attractive if the charges are of opposite signs. Note that Coulomb's law is like Newton's law of gravity, but unlike gravitational forces that are always attractive, electric forces can be either attractive or repulsive. And this is all for this video. Thank you for watching.